Hello, welcome to our channel. So in this video we will discuss the topic drift speed or drift velocity. So when conductor not in a connection, when the conductor is not connected to the circuit, the electrons are in a conductor or in random motion. When the conductor is connected to the battery terminals, those electrons will move in a specified direction with a constant speed. So this constant speed is called drift speed or drift velocity. Now consider a conductor connected to a battery to make the current flow. Then these electrons will move in a specified direction with a constant speed. Okay. Now consider any cross section in a conductor. So consider a cross section area of A in the conductor, and Vd is drift velocity of the charges. Let Vd is drift velocity of charges, and n be the number of charges in the conductor, number of charges in the conductor in a unit volume, then the distance covered by one charge. Okay, the distance covered by one charge in 1 second is Vd. So we know that Vd nothing but drift velocity. So a drift velocity or any velocity is defined as distance by time, right? So distance covered by one charge is Vd, and one charge. So we are considering a volume of cross sectional area. So then the volume of conductor for the same distance, the volume of conductor for this distance is A into Vd. Number of charges present, n number of charges present in that conductor in unit volume. Then number of charges present in that volume equals to n into AVD. Number of charges present in that volume equals to n into AVD. And let Q be the charge of each carrier. Let Q be the charge of each carrier. Then the charge crossing the cross-sectional area A at this point D in 1 second is equals to n into Q into A into Vd. This is nothing but electric current I. How means the amount of charge crossing the cross-sectional area A in 1 second is equals to electric current, is nothing but electric current. So I is equals to n into Q into A into Vd. Therefore Vd is equals to I by n into Q into A. So Q is in this equation, Q is charge of each carrier. If the charge is positive, then the charges will move in the direction of flow of current. If the charge is negative, If the charge is negative, those charge carriers will move in the direction opposite to the flow of current. In this, the conductor, in the conductor, charge carriers are electrons. Then the value of Q is equals to E, and the magnitude of E is equals to 1.602 into 10 to the power of minus 19 coulombs. So if you observe the current equation here, I is equals to N into Q into A into Vd. So here N and A are numerical numbers. Okay, that means N and A are constants. So the direction of flow of current is determined by the sign of Q and Vd. For positive charges, the product of Q and Vd is positive. Then the direction of current flow is along the direction of current flow is along the direction of positive charges. If charge carriers are negative, the product of Q and Vd is negative. This represents the direction of current flow is in the opposite direction to the flow of negative charges. Next topic, potential difference. Already we know free electrons are in a conductor, free electrons are more. When that conductor is connected to a battery, an electric field set up throughout the conductor in this direction, and this electric field this electric field exerts some force on free charges. So due to that force acting on them, free charges will accelerate. So if the charges are positive, they move or they accelerate in the direction of electric field. If the free charges are negative, the force acting on them is in the opposite direction of electric field. See here, so this is the electric force acting on positive charges due to this electric field, and which is in the direction of electric field, and this Fe is force acting on negative charge, and that is opposite to the electric field. So here we can say that this electric field or electric force is doing some work by moving the charges in a specified direction. Okay, so now consider a conductor. So, and the force acting on free charges is Fe. That electric force Fe will move the charge from point A to point B through a distance L. Okay, then the work done is W is equals to, so in general work is nothing but force into distance. So W is equals to Fe into L. So work done on a unit positive charge, work done on a free charge due to electric force is W is equals to Fe into L, and work done on a unit charge, work done on unit positive charge, work done on unit charge. So work done on unit charge is W by Q. So W is nothing but Fe into L and Q. So potential difference is is denoted by V. So V is equals to W by Q, which is nothing but Fe into L by Q. So potential difference is defined as work done by the electric force to move a unit charge through a distance L from point A to point B. Okay, so this is called potential difference, and it is also called as potential difference between point A and point B. So potential difference between point A and point B, we can say. So 1 volt is equals to 1 joule by 1 coulomb. Next topic, EMF. So when a conductor is connected to a battery, the negatively charged electrons will move from negative terminal of the battery to positive terminal of the battery in this way. So when conductor is connected to battery, the negative terminal, the negatively charged electrons will accelerate with a constant speed, that is drift speed, from negative terminal of the battery to the conductor to positive terminal. So why? Because electric force is acting on them. So because of electric force acting on them, so the negatively charged electrons will move from negative terminal to positive terminal of the battery. And we also know the potential difference across the battery terminals is maintained constant. But here what happened when it is connected to this? These negative electrons are going out and they are coming to the positive terminal. So thereby imbalancing the potential difference across the battery terminals. So at this time, same amount of negative ions present at this positive terminal will move from positive terminal to negative terminal of the battery by chemical force acting on them against electrical force. Okay, so due to chemical force acting on them, the negative ions present at the positive terminal of the battery will move from positive terminal to negative terminal of the battery against Fe, electric force Fe. So here this chemical force Fe is doing some work. Okay, so here chemical force is doing some work. So that work done by the chemical force to move the charge from positive terminal to negative terminal is called EMF. Okay, so the work done by the chemical force to move the negative charge from positive terminal of the battery to negative terminal of the battery is called EMF. So W is given by W is equals to work done is equals to Fc into D, and work done by the chemical force on unit and 1 coulomb of charge is W by Q. So Fc into D by Q. So EMF is equals to W by Q. EMF is equals to W by Q. So which is nothing but Fe into D by Q. So we know that Fe is equals to Fc when the potential difference across a battery is constant. Okay, so when these are moving from negative to positive terminal, okay, and also due to chemical force, the amount of negative ions present at the positive terminal will also move to the negative terminal of the battery, thereby maintaining constant potential difference across battery terminals. Okay, so EMF is equals to Fe into D by Q. So EMF is defined as chemical force, work done by the chemical force, to move a unit positive charge, from negative terminal of a battery to positive terminal of the battery. Okay, so when the battery is at constant, when the potential difference across the battery is constant, then Fe is equals to Fc. So under this condition, EMF E is equals to Fe into D by Q. So where D is distance between the positive terminal to negative terminal of the battery. D is distance between the two battery terminals. This distance is T. Okay, thank you.